Okay, so what I want to show you just real quickly is how to do this on the calculator. This example that she has, the logging in the rainforest. Okay, so doing a hypothesis test, she used the formula here to get t equals 2.11. So I just want to show you how we do that on the calculator, okay? So usually what I tell my students is, our favorite button is stats. You may not agree after this class, but so we go into edit here. Can you see that okay? Be better like that. Okay, we go into edit, we hit enter. Okay, and you'll see the two lists here. So what I had done is just going into L1 and put the log data in L2. I'm sorry, L1 I put the log unlogged, and L2 I put the log. Do you see that? Okay, so do second quit. All I'm going to show you is how to get that formula. You can still follow her steps. So we go stat, we go over to test, and you can see we have the z-test, t-test, 2 sample z-test, 2 sample t-test. So the one sample that you did in chapter 17, you could get those here. These formulas in 2 samples are just a little more complicated, so it's definitely easier to get the actual test statistic off the calculator. I'm going to go into 2 sample t-tests, hit enter. Because I typed it in L1 and L2, we're going to use data. If you had put it in a different list, you would put that here. Frequency stays 1. Okay, and then the alternative is whatever we have in our alternative here. Okay, so if you're not sure how she got this, I just write unlogged, logged. My first sample is unlogged, second sample is logged. And because the question was, does logging significantly reduce the mean number of species in a plot after 8 years? Follow the force. Okay, if it reduces it, this one will be smaller, right? So you point to the smaller number. That's what's going to go in your alternative. Whoops. We do mu1 equals mu2 in the null. The equal sign is always in the null. The alternative is whatever we decided here. And Dr. Derwalla likes to write them where you have it on one side. So mu1 minus mu2 equals 0. Mu1 minus mu2 is greater than 0. Okay, so we put that in here. The pooled is if the standard deviations are equal. We're going to say no there. I usually just tell my students just say no. And we hit calculator. Okay, so you can see the t-test statistic that she had gotten was 2.11 using the formula. And that's what we got here. So it just saves you a little time. The p-value is 0.02595, so if you round, 0.026. Okay, whereas when you're using the table, you can just estimate what two values the p-value is between, but the calculator actually gives you the p-value. Okay, and since our alpha was 0.05, this is clearly less than 0.05, so we reject the null, meaning we do have enough evidence to show the alternative. Okay, same thing is true with the confidence intervals on these 2 sample ones. Instead of using this whole formula here, we can do stat, test, and go all the way down to 2 sample t interval. We do it exactly the same way and hit calculate. Now, here you have to put the confidence level in. So she had said 0.9. We hit calculate, and it gives us the confidence interval. Now, ours is going to be a little more exact than what she got here on the paper because when you use the table, it does round it. But both numbers are still positive. If both numbers are positive, it's showing you the first one is bigger than the second one. Okay? If you have, oops, my computer. If you have any questions at all, just let me know. Thanks.